I'm going to do a more involved example of while loops, and this example has three different functions. I have my partial series function, which accepts an integer and returns an integer, and then I have my add series function, which will take an integer and return an integer, and then I have, of course, my main function, which only calls the add series function and passes the integer value 3. And then whatever add series returns will be displayed. So when I run my program, the main module will execute first, which calls add series and passes the number 3. So add series is called, and it creates a parameter n, which will be assigned the passed value 3. And within that function, we'll create a variable called num and assign it 1, and then a variable sum and assign it 0. And then while n is less than or equal to n. So while num is less than or equal to n, I'm going to add something to sum and then increment num by 1. So when we're walking through this, we should be able to determine that this while loop is going to execute 3 times. Num will start at 1, and we're going to loop, and in each iteration we'll add 1 to num, so it will be 1, and then it will be 2, and then it will be 3. When num reaches 4, the loop will no longer execute because then num will be greater than n. So try to look at the problem and try to figure out what the pattern is that will be happening. So the first time we jump in this loop, we're going to add to sum on line 18 the contents of sum, and then whatever this function call returns. So this is where it gets kind of tricky. We're going to call partial series, and we're going to pass it a copy of the current contents of num. Well, num currently has a 1 in it, so when I pass this up to partial series will create a parameter value n, and it will be assigned a 1. And then in this function, I'll create a num variable, assign it a 1, and a sum variable, and assign it 0. And then while num is less than or equal to n, well, in this function, num and n are both 1. So remember, the variables can have the same names in different functions because they only have scope within the function that you are in. So the partial series function has the variables n, num, and sum, but those are different variables than the ones that we declared in add series. So on line 5, we're going to loop while num is less than or equal to n. Well, 1 is less than or equal to 1, so I'll jump into the loop. I'll add sum and num together and then put it back into sum. So sum and num are 1, and I'm going to put it back into sum, and then I'm going to increment num by 1. And then when I go back up and test, the condition will be false, so I'll return the contents of sum. So when I passed, and it'll come back down here. So this right here evaluated to whatever was returned, and that happened to be a 1. So now I'm going to say sum plus 1. Well, in this function, sum is 0. So sum plus 1 would be 1, and I'll put it back into sum, and so that's a 1. And then I'll add 1 to num, and I'll go back up. Num is still less than or equal to sum, so I'll jump into the loop on line 18. I'm going to call partial series again, and this time I'm going to pass it num, which now contains 2. So partial series will be called, and when it's called, it will again create the parameter n, and it will hold the value 2. Num will be created. It will hold a 1, and then sum will be created, and it will hold a 0. And now while num is less than or equal to n, add sum and num and put back into sum. And then add 1 to num. And then go back up. Is num still less than or equal to n? That's still true. So add sum and num. So 2 plus 1 is 3, and add it back into sum. And then add 1 to num. And then go back up, and this will be false. So I'm going to return sum, which is a 3. Okay, so this time evaluated to the number 3. And so this statement on line 18 says add sum and 3. So sum plus 3 is 4, and put it back into sum. And then increment num. And then go back up. And num is still less than or equal to n. So I'll hop back into the loop. And I'll add sum plus the call to partial series, and this time when I pass num, I'm going to pass it the number 3. So 3 will be passed to partial series, and it will be stored in the parameter n. Num will be created with a 1, and sum will be created and initialized to 0. And then while num is less than or equal to n, add sum and num. So 1 plus 0 is 1, and put it back into sum. And then increment num. Then go back and check. Num is still less than or equal to n. So add sum and num. So 2 plus 1 is 3, and put it back into sum. And then add 1 to num. And num is still less than n. 3 is less than or equal to 3, so that will still be true. And then add sum and num. So 3 plus 3 is 6. And then add 1 to num. Now num is not less than or equal to n, so return sum, which is 6. So when I called partial series and I passed it 3, this evaluated to 6. So this statement on line 18 says add 6 plus sum. Well, sum is 4, and you can 6 plus 4 is 10, and put that back into sum, and then want to add 1 to num, and then go back up on line 17, and that condition will now be false. So this one says return sum, so the current value in the sum in this function is 10, and when I return back, I'll display the value that was returned. So in the terminal window, you would see the number 10. Now if you noticed, what we did was when we passed 3, we looped here. So we looped 1, 2, and 3. And then for each of these numbers, we looped 1 to 1, and we summed them up here on line 6. So 1 to 1 would have looped 1 time. And then when we passed 2, that added, that summed up 1 plus 2. And then when we passed 3, that summed up 1 plus 2 plus 3. So what this entire loop did was it added 1 plus 1 plus 2 plus 1 plus 2 plus 3. Right? This was the first call to partial sum when the value num was 1. And this was the second result, and this was the third result. Okay, so that was kind of a difficult problem to hand trace, and that would take you a lot of time on the exam. So in the next video, I'm going to show you how you could just quickly write this out using a, in a Python program to find the answer.